We're looking at the Math 2 Unit 12 review. So we'll start with number 1 here. We're looking at a graph of negative x squared minus 9. Let's rewrite this as just negative x squared plus 9. So if I distribute out the negative, it makes it a little bit clearer to see. So the first one asks, is f of x decreasing when x is greater than 0? So for this one, we look at anytime x is greater than 0, it's going to be on the right-hand side of the axis of symmetry, or y-axis here. And if we look at it, it is always going down, so it is decreasing. We put true. For B, we have the axis of symmetry as y equals 0. Now, it is on 0 because this is the y-axis, but this is false because it should be x equals 0. Whenever axis of symmetry comes up, it's x equals 0. C, the maximum value of f of x is 9. If we look here, our maximum or our vertex is at 0, 9. So it's our maximum. True. 2, 5 is a solution for f of x. So if I can count over and look at the point 2, 5 does exist there. So that would make it true. I could also plug it in to my function up here. Put a 5 equals negative 2 squared plus 9. I get negative 4 plus 9. It does come out to be 5. So that's true. Negative 1, 3 is a solution of f of x. Well, here, that would be right at that point. It is not on the line. We could also plug in that to our function, and it would be 3 equals a negative of negative 1 squared plus 9. This comes out to be 8 equals 3. It's not true, so that is false. 3, 0 is an x-intercept of f of x. If I come down and look at the x-axis, I hit at negative 3 and positive 3. So 3, 0 is an x-intercept. 0, 9 is an x-intercept of f of x. That is partially true. It is our y-intercept, but is not our x-intercept, so that is false. Axis of symmetry is x equals 0. That's kind of like what we mentioned up here on B, so that is true. F of x opens down because of the subtraction sign before the 9. So that's referring to this right here, and that's actually false. What's the part that makes it go down is the negative out in front of all of it, which makes it the coefficient in front of the x squared is negative. So we're going to put a false on that. Vertex is 0, 9. We've already mentioned that. It's true. The value of x when f of x reaches its maximum is 0. So when I reach my maximum here, which is my vertex, which is 0, 9, the value of x is 0. The value of y is 9, but we wanted the x, so that is true. For 2a, the domain of f of x, for this, is going to be all real numbers. The range of f of x, the y values that work, is it maxes out at 9 and it's everything below that. So it has to do with 9 and y. So we're going to say y is less than or equal to 9 because all values less than or equal to 9 do work. Our rule for translating x squared to f of x. Well, x doesn't change at all, so x is going to stay. What we do to y is we move it up 9. So we're going to add 9 to that. And what also happens is the y values flip. And because the y values flip, I'm going to make it a negative y plus 9. So you go up 9, and then you take the opposites of them because they start to go down from that. The average rate of change from 0 to 1 and 2 to 3. So I'm going to write out a list here of my values. So this is x and f of x. So 0, 1, 2, 3. A couple of these I already know. I know I go 0, 9, and 2, 5. If I plug in a 1, we found that earlier, that's an 8. And then 3 is 0. So my rate of change from 0 to 1, I went from 9 to 8. It means I went down 1. My rate of change from 2 to 3, I went down 5. So it's minus 5. So my rate of change, 0 to 1 is negative 1. 2 to 3 is negative 5. This is also what we'd call the slope. You could always use slope formula for that. For number 3, we're looking at our points here. We can plot these. actually, we're going off the grid. So let's, let's just kind of work our way through this, a few things, before we sketch it. So x-intercepts, we want to find when x, or when y is 0. Those would be our x-intercepts. And then we have those right there. So it's going to hit at -5 and 1. The y-intercepts are when y, we get a value for y and x is 0. So that is 5 here. The value of x when k of x is at its maximum. So this one, I go -7, 0, 5, 8, 9. So it's getting bigger. Then it goes 8, 5, 0, 7. So that is the maximum right here. So the value of x at its maximum is -2. So that means the maximum value is 9 in the function, which means our vertex, which is at the maximum, is -2, 9. Now, k of x is increasing when x, let's see, it's going up, 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 stops and goes down. So that's going to be when x is less than 2, or -2 here. So anything less than -2. And then it's decreasing after that, so it's going to be decreasing when x is greater than -2. Number 4, we need to match the equation to what characteristic it reveals without changing its form. If I look at the first one, this is factored down, so I could set each of these parts equal to 0 and get the zeros, the solutions, or the x-intercepts. So I'm going to say that 2 goes to A. If I look at C, this helps me find the vertex really easy, which is 227. So that I'm going to put as the maximum value. So go C. And B is in that standard form. What this lets me do is if I let x equal 0, I can plug in the zeros. I get 15. That's also known as our y-intercept. And that would be really come in handy when I plug in x for 0, get m of x, y-intercept. So I'm going to put a B there. So that's C-A-B. Number 5, we're going to factor and then look to see what we have, plug in some values that work. If I look at 2x squared plus 7x minus 15, I'm looking at ways I can multiply to -30 that add to 7. I see positive 10, -3. So I'm going to do 2x squared plus 10x minus 3x minus 15. I broke apart the middle term into 10 and -3. I now factor by grouping. Factor out of 2x, I get x plus 5. Factor out of -3, I get x plus 5. So I'm going to have 2x minus 3 and x plus 5. So I'll go 2x minus 3 and then a 1x, just x, plus 5. Over for this one, I'm looking at negative or positive 50. Multiply to positive 50, that adds to -51. If that's the case, I'm going to use -50 and -1. So we go 5x squared minus 50x minus x plus 10. Factor out of 5x, I got x plus 10. Factor out of -1, actually x minus 10 actually, on the first one. Factor out of -1, I get x minus 10, so I get 5x minus 1, x minus 10, so 5x minus 1, 1x minus 10. Number 6, we need to solve by using our quadratic formula. Quadratic formula, to remind us, is -b plus or minus the square root of b squared minus 4ac, all of it over 2a. So we're going to plug in the values that we have. A is 5, b is -7, c is -3. So our b value is -7. I'll put it here and here. A is 5, so that's going to go down here and here. And c is -3, goes there. Now the last two that we have, this one is always a 4, and then this one is always a 2. So now we have to simplify and solve for this. So let's make it 7 plus or minus the square root of 7 squared is 49 minus, that's 20 and 3 is negative 60 over 10. So now we're going to do x equals 7 plus or minus, that's a 109 over 10. Square root of 109 over 10. If we look at the square root of 109, it's not divisible by 3. It's not divisible by 7. It's just not going to reduce down, so we're going to leave it as an irrational number. That's kind of its simplified radical form. So we could either write it like this, 7 plus or minus the square root of 109 over 10. We could also break it into two separate ones, 7 plus the square root of 109 over 10, and 7 minus the square root of 109 over 10. You could also just write it as separate fractions, 7 over 10 plus or minus the square root of 109 over 10. All of those would be the same way to write it. Okay, we're now on to the pages from 833 to 835. We're going to do 1 through 12, 18 to 30, and 39 to 47. So, looking at number 1, we need to graph, actually 1 through 8 all the same. We're going to graph each function and then label the axis of symmetry and the vertex. So we start with y equals 2/3 x squared. Now if we go through the process of trying to find the axis of symmetry, it's really plus 0x plus 0 if we write it out to that standard form. So x equals negative b over 2a is 0 over 2 times 2/3, so it's 0. So what that means is our axis of symmetry is 0. If we then go back and plug that into our equation, we get that y equals 0 as well, because 2/3 times 0. So your vertex is 0, 0. So we go to sketch. Axis of symmetry is on the y-axis. Vertex is at 0, 0. That's the equation for 2/3 x squared. Now, what it is different, since it is 2/3, it should be a little bit wider than if it was just x squared, but there's our sketch for that one. Number 2, we have y equals negative x squared plus 1, which we could expand out and call that y equals negative x squared plus 0x plus 1. Because when we do negative b over 2a, we get negative 0 over 2 times negative 1, which is 0. We plug that in to get our vertex. It comes out to be negative 0 squared plus 1, or just 1. So our vertex is at 0, 1. And you should hopefully notice by now your axis of symmetry is the x value in the vertex. So here, we have negative x squared plus 1. We're at 0, 1, so we shifted up 1, but also with the negative, it's pointing down. So the parabola would look like so. Number 3, we have y equals x squared minus 4. Now if we just kind of look at the parts we have there, a minus 4 means it shifted down 4. So 0, negative 4 is our vertex. It's positive out here, so it opens up. And then our axis of symmetry is going to be x equals 0, because it again is on the y-axis. Number 4, we get y equals 5x squared plus 8. Now, the 5 indicates that it's going to be more narrow because it's being stretched up and pushed together. The 8 tells us our y-intercept is going to be up here at 0, 8. Positive 5 says it's going to be opening up. So our vertex is 0, 8, and our axis of symmetry is x, or x equals 0. Number 5. finally get one to work with here. So first, our axis of symmetry, we're going to do x equals negative b over 2a. Negative 4 over 2 times 1/2 comes about to be negative 4 over 1, or negative 4. We now put that into our equation, and we get 1/2 times negative 4 squared plus 4 times negative 4 plus 1. This becomes 16. Half of 16 is 8. Minus 16 plus 1. I got 9 and 16, so that's going to be a negative 7. So our axis of symmetry is x equals negative 4, and our vertex is negative 4, negative 7. So we're over here. And positive out in front of the 1/2, it's saying it's going to be a little bit wider. What we could use is use that 1 if we make all the x's 0, kind of gives us a reference point for where it's going to go through. So we're at negative 4, negative 7. This is 0, 1. Now if I went over 4 up to 1, if I go 4 this way to negative 8, 1, it's also another point that it hits. Number 6, doing y equals negative 2x squared minus 3x plus 10. We're going to do x equals negative b over 2a to find our axis of symmetry. Looks like we have 3 over negative 4. So we then plug that into our equation. Negative 2 times negative 3/4 squared minus 3 times 3/4 plus 10. We have negative 2 times 9/16 minus 9/4 plus 10. We have negative 18/16 minus 9/4 plus 10. I'm going to make them all have a denominator of 8, because I can reduce this and make it negative 9 over 8, which becomes the next one, negative 18 over 8, and then plus 80 over 8. So 9 and 18 together are negative 27 over 8. With a positive 80 over 8, we get 53 over 8. So our vertex comes out to be negative 3/4 and 53 over 8. If we wanted to convert those, this is negative 0.75, and 58 over 8 is 7.25. Gives us a little better idea that we want, but vertex is there. Axis of symmetry we found was negative 3/4. If we go to sketch, we're going left 0.75 up 7.25, so this is negative 3/4, 58 over 8. And it is going down. We know it actually goes through 10 on its way down. So at 0, 10, because if I make my x's 0, just left with a 10. So then I could come to the other side. If I went another 3/4, that would be 3/4 and 3/4 would be 6/4 would be 3.5. So we do 3 over 2, 10 would be another point that it could go through. Number 7, we get y equals 1/2 x squared plus 2x minus 3. We'll do x equals negative b over 2a. Gives me negative 2 over 2 times 1/2, or negative 2 over 1, negative 2. We plug that into our equation. Negative 2 squared is 4. Half of that is 2. Minus 4 minus 3. We have negative 5. So our vertex is negative 2, negative 5. Axis of symmetry is negative 2. So negative 2, negative 5 puts us here. It's a 1/2. It's going up, and it goes through negative 3. So could also throw a point over here. We went over 5. Oh, let's switch that. Should be negative 2, negative 5. We went over 2, so it'd be another 2, and that would be our other point. last one of the set, number 8, y equals 3x squared plus x minus 5. X equals negative b over 2a gives us negative 1 over 2 times 3, or negative 1/6. We then plug that into our equation to find our vertex. We'll do negative 1/6 squared plus negative 1/6 minus 5. This gives me 3 times 1/36 minus 1/6 minus 5. 3 and 1/36 is going to be 1/12. Let's convert them all to have a denominator of 12. Looks like we have a negative 62 and a positive 1, so it's going to be a negative 61 over 12 for our vertex. So negative 1/6 and negative 61 over 12. Give us an approximate idea. 61 over 12 is about 5.1. So we're somewhere down here. It is opening up. It does say we go through 5. So we know we at least hit 0, negative 5, and then our vertex was negative 1/6, negative 61 over 12. Leave it as a fraction. It's perfectly fine. And there's our graph. Okay. Now on number 9, it says give an example of a quadratic function that matches each description. So number 9, it opens down. So if I'm writing my equations, what has to be in the place if I have this form to go down? Now, if the a value is negative, it's going to open down. So anything with an a value negative. It doesn't matter what the rest of it is, as long as that first term in front of the x squared is negative. Let's make it a y equals negative x squared. That would work. We could do negative 2x squared minus 5x plus 7 if we wanted, as long as it's a negative. If we look at number 10, vertex of the graph is at the origin. So the vertex has to be 0, 0. So one way is if we do the x minus negative b over 2a, that has to be 0. Then when we plug it in, it also needs to come out to be 0. But what we're seeing is the basic form x squared. Anything with an x squared by itself will go through the origin. Basically, we need no b value, because if you have no b value, x comes out to be 0, and then you have nothing added on, it comes out to be 0 as well. So just leave it as an x squared, throw a coefficient if you want in front of it, make it open up or down, but it'll always go through the vertex. If we look at 11, we want it to open up. Now that's going to be the opposite of number 9. 9, we said if we had ax squared plus bx plus c and a was negative, it goes down. When it's positive, it goes up. So anything with a positive coefficient will open up. Number 12, graph is wider than the graph of y equals x squared. So we want something ax squared where our a value makes it wider. Now the smaller the coefficient value is relative compared to 0, because it gets closer to 0, the wider it's going to get. So we just need this to be less than 1. So I could do like a 1/2 x squared would be wider, 1/5 x squared would be even wider, 1/10 x squared would be even more, and I could even flip one and make it like a negative 3/4 x squared. All of those would be wider than an x squared because that coefficient gets closer to 0. Okay, now we jump to number 18. We need to solve the equation. If it has no real solutions, we'll write no solution. So 18, we have 6 times x squared minus 2 equals 12. First thing to do is divide over the 6. Divide that over, I have a 2. I'm going to then add 2 over. I get x squared equals 0. If I take the square root to both sides, the square root of 0 is 0. So my one solution is x equals 0. If we go to 19, we have negative 5m squared equals negative 125. We divide both sides by negative 5. Be careful with the negative. It gives you a positive 25. We now take the square roots of both sides, and because it could be a positive or negative, I put plus or minus root 25. So m equals plus or minus 5. So you could have m equals 5 and negative 5. So you have two solutions for that. Number 20, we have 9w squared plus 1 equals 9. Divide both sides by 9. We get w squared plus 1 equals 1. W squared equals then 0. So w equals 0 is our solution. For 21, we have 3r squared plus 27 equals 0. I'm going to subtract over the 27, so that equals negative 27. Divide by 3 gives me negative 9. And now I take the square root of both sides. But the problem we have is I can't take the square root of a negative. There's no way I can multiply a number by itself and get a negative. So that won't let this happen. So anytime you try to take the square root of a negative, we're going to write no solution for now. It's actually no real solution because you could have an imaginary solution, but that's later on. For 22, we have 4 equals 9k squared. I'm going to divide both sides by 9. I get 4/9 equals k squared. I'm going to reduce that to, no, I can't reduce that. I'm going to take the square root of both sides. Plus or minus the square root of 4 over 9 equals the square root of k squared. I get a k on the right-hand side. This is the same as writing on the left-hand side, the square root of 4 over the square root of 9, which are both perfect squares. And that comes out to be 2 and 3. So we're going to get k equals a positive 2/3 and a negative 2/3. 23 is 4n squared equals 64. I'm going to divide both sides by 64. And I get 16. Square root of both sides. I get n equals plus or minus 4. So n is 4 and negative 4. Now for number 24, we have x squared plus 7x plus 12 equals 0. So now I'm going to look at some of my factoring strategies. Now as I go through these, I could use quadratic formula if it doesn't factor nicely. If some of the factoring doesn't work for you, by all means, use quadratic formula. It will get you there, but some of these processes are a little bit quicker. So one thing I can look at is I want to multiply to 12 that adds to 7, and I can quickly see 3 and 4 would do that for me. So I'm going to write x plus 3, x plus 4 equals 0. Then by the zero product property, I set each of those equal to 0. And I get x equals negative 3 and x equals negative 4. And those are my two solutions. If we go to 25, we have 5x squared minus 10x equals 0. Now it's not a quadratic three-term trinomial, but what I can do is take out a 5x. If I take that out of the first term, I'm left with an x, and the second term I have a minus 2. Now I set 5x equal to 0 and x minus 2 equal to 0. So x equals 0, x equals 2. They're my two solutions. 26. We have 2x squared minus 9x equals x squared minus 20. I'm going to get everything to one side, so I subtract over the x squared. I'm left with a single x squared minus 9x plus 20. So can I multiply to get to 20? That adds to negative 9. Since this is positive and I want a negative sum, I could do negative 5 and negative 4. So I'm going to do x minus 5, x minus 4 equals 0. X minus 5 equals 0, x minus 4 equals 0, so I get x is 5 and 4. For 27, we have 2x squared plus 5x equals 3. We're going to bring over the 3 and make it a negative 3, so it's equal to 0. We're looking now at multiplying between these two to get negative 6. And we want to add to get a 5. So I'm going to multiply to get a negative, but it adds to be a positive. So one's positive, one's negative. If I did 6 and negative 1, that would add to 5, and it would multiply to be negative 6. So it's not that I'm going to write it as x plus 6 and x minus 1. I'm going to break up this term, this 5x. So make it 2x squared plus 6x minus 3. I then factor out of the first two terms. A 2x leaves me with x plus 3. The next two terms I factor out a negative 1, leaves me with x plus 3. So I have x plus 3 in common. 2x minus 1 is the leftovers. So I now set both of those equal to 0. X plus 3 equals 0. 2x minus 1 equals 0. X equals negative 3. And then 2x equals positive 1, and x equals 1/2. For number 28, we have 3x squared minus 5x minus 3x squared plus 6. I'm going to, 3 equals there. I'm going to add over the negative 3x squared, gives me a 6x squared. Still a negative 5x, and then a minus 6 when that's subtracted over. I'm looking at multiplying to negative 36, and it's going to add to negative 5. So really, it's a negative product. So one's positive, one's negative. So what can I do with 36 where it's going to be 5 units apart? If I look at 9 and 4 give us 36. They are 5 units apart. So we're going to make it negative 9, positive 4. So that's going to be a 6x squared plus 4x minus 9x minus 6. We're going to take a 2x out. We get 3x plus 2. Then take out a negative 3. Leaves us with 2x or 3x plus 2. 3x plus 2 is in common. 2x minus 3 is left over. Set each of these equal to 0. We have 3x equals negative 2. Then that's going to be an x equals negative 2/3. Other side, 2x equals 3, x equals 3 over 2. So our two solutions are negative 2/3 and 3 over 2. For 29, we get x squared minus 5x plus 4 equals 0. We want to multiply to 4. That adds to negative 5. Negative 4 and negative 1 would satisfy that. So we can do x minus 4 and x minus 1. So that's going to be, set that equal to 0, and I get 4. That equals 0, I get 1. So it's 4 and 1. For number 30, we have the area of a circle is given by the formula area equals pi r squared. R is the radius of the circle. Find the radius of the circle with area 16, and we're solving for r. So if I go 16 is the area equals pi r squared, I could divide by pi. I get 16 over pi equals r squared. I know pi is 3.14 approximately, so we're just going to leave it like that. I take the square root of both sides, and I get r equals, well, the square root of 16 is 4 over the square root of pi. So it's r equals plus or minus 4 divided by pi. So I could do, or the 4 divided by the square root of pi. So 4 divided by, we do pi, and then its square root equals, it comes out to be approximately plus or minus 2 point, what do they want, the nearest tenth, so we'll go 2.3 inches. So it's a positive 2.3 inches and a negative 2.3 inches. On number 39, we have x squared plus 7x minus 10 equals 3. We're going to bring the 3 over. X squared plus 7x minus 13 equals 0. I don't have a way that I can multiply to negative 13 to add to 7, so this is where I'm going to start using the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac over 2a. You got to know it. You got to be able to use it. So let's plug in some values. A is 1 here, b is 7, c is negative 13. So I'm going to go negative 7 plus or minus the square root of b squared is 49 minus 4 times 1 times negative 13. All of that's over 2a, which is just 2 times 1, 2. So negative 7 plus or minus. All right, 49. 4 times 13 is 52, so that's plus 52 over 2. If I add that together, I get 101. So I get the square root of 101. It's an irrational number. I can't really simplify it anymore, but really all it asks here is the number of real solutions. So I can get that. It works, so I'm just going to say 2 solutions. If we look at number 40, we got 3x squared minus 2 equals 5x. 3x squared minus 5x minus 2 equals 0. We could, let's just use quadratic formula for this one. We're going to do negative of negative 5 plus or minus the square root of negative 5 squared minus 4 times 3 times negative 2 over 2 times 3. And really, since it's asking for the number of solutions we want, we can really just use the square root or the determinant to help us. So I'm just going to focus on that. I get 25 minus a negative 24, which comes out to be 25 plus 24, or a square root of 49. The fact that's positive guarantees we always have 2 solutions. If it came out to be a 0, we would have 1 solution. If it came out to be a negative, we'd have 0 solutions. So we get 2 solutions. We could simplify it further, but frankly, it ain't asking for it here, so we're not going to do that. So now we're going to go to 41. We have 4x squared plus 3x minus 8 equals 0. Let's go quadratic formula. That's going to be negative 3 plus or minus 3 squared is 9 minus 4 times negative 8. All of that's over 2a, which is just going to be 8. So I have 9, and then 4 times 8 is 128, so that's plus 128. And I'm going to add 9 to that. I get 137. So I get negative 3 plus or minus the square root of 137 over 8. We're not going to be able to simplify that, but it asks for it to the nearest hundredth. So one way I could write it is x equals negative 3 plus the square root of 137 over 8. And the other one is x equals negative 3 minus the square root of 137 over 8. So we'll plug it in the calculator, see what we get. So we go negative 3 plus 137 as a square root, and then divide by 8. And I get about 1.09. It's actually 1.088. We'll call it nearest hundredth. And then negative 3 minus 137 in the square root divided by 8, we get about negative 1.84. Our 2 solutions are here. Let's go to 42. 2x squared minus 3x equals 20 becomes 2x squared minus 3x minus 20 equals 0. In our quadratic formula, we're going to do a negative of a negative b, which is a negative, so it's going to be 3 plus or minus the square root of, that's 9 minus 4 times 2 times negative 20. Change the sign because it's a negative already, and then squared it, so I got 9. 2 times 2 is 4 on the bottom. 3 plus or minus, I got 9, and it looks like 160 over 4. 3 plus or minus the square root of 169 over 4. 169 is nice because it is a perfect square. So I have 3 plus or minus 13 over 4. So one way we could do it is we go 3 plus 13 over 4, which is 16 over 4, or 4. The other one is x equals 3 minus 13 over 4, negative 10 over 4, which is negative 5 over 2. (43), we have negative x squared plus 8x plus 4 equals 5. Bring it over, we have negative x squared plus 8x minus 1. A, b, and c are given. So we're going to go negative 8 plus or minus the square root of 64, that's 8 squared, minus 4 times negative 1 times negative 1 over 2 times negative 1. So I got negative 8 plus or minus. All of this comes out to be a negative 4, so it's 64 minus 4, which is 60, and that's over negative 2. So we could write it here as x equals negative 8 plus the square root of 60 over negative 2, or x equals negative 8 minus the square root of 60 over 2. So let's see what we get here. Get about 0.13 for the first one. Second one, I get about negative 7.87. Okay, 44. We have 64x squared plus 12x minus 1 equals 0. We have a, b, and c. So x equals negative 12 plus or minus. B squared is 144 minus 4 times 64 times negative 1 over 2 times 64. This becomes negative 12 plus or minus 64 times 4 is 256. I'm going to add 144 to that, and I get 400 over 128. It's 2 times 64. 400 is nice because that is 20. So really I have x equals negative 12 plus 20 over 128, and x equals negative 12 minus 20 over 128. We get a 8 over 128 here. That comes out to be 0.06, so it's 0.0625, call it 0.06, they want it to the nearest hundredth. And here we have negative 32 over 128, and that comes out to be 1/4, or negative 0.25. Okay, on 45, we're looking at solving. We have 5x squared minus 10 equals x squared plus 90. I'm going to move everything over to the same side. I get 4x squared, and it looks like a negative 100 equals 0. I could use quadratic formula here, but I recognize this as a difference of two squares, which is a squared minus b squared gives you a plus b, a minus b, if you remember that. So I'm going to make this 2x minus 10 and 2x plus 10 equals 0. So when I set each of these equal to 0 and solve, I get 2x equals negative 10. That gives me x equals negative 10 over 2, which is negative 5. 2x equals negative 10, x equals negative 10 over 2, which is positive 5. One of these is wrong. Oh, that should have been a positive. Okay, so I get 5 and negative 5, and again, I use difference of two squares. For number 46, I got x squared minus 6x plus 9 equals 0. Multiply to 9 adds to 6. It sounds like I can use 3 and 3. But since they're actually the same, it's really just going to be one solution. I say x minus 3 equals 0, and I get x equals 3. Factored it down, it's one solution. 47, a ball is thrown into the air. The height in feet as the ball can reach and modeled by their equation, h equals negative 16t squared plus 20t plus 6. Just like that. So when will the ball hit the ground is what we need to know. So it starts here at 6 feet in the air. It goes up, reaches its vertex, and it comes back and hits the ground. What we're really looking for is not the vertex. We're looking for the solution when it hit the ground. Now realize if we extended and made time negative over here, it would also hit over here. But we don't really worry about the negative time. We always normally just pay attention to positive time in the context. So what we're going to do is we're going to solve this equation and find the zeros. Before I do that, I'm going to divide everything by 2, just to make numbers a little smaller. I get negative 8t squared plus 10t plus 3. I could look at factoring, or I could use quadratic formula. Since that's the common theme, I'll use quadratic formula. I get negative 10 plus or minus the square root of 100 minus 4 times negative 8 times 3. And all of that is over 2 times negative 8. We get negative 10 plus or minus here. 4 times 8 times 3 is 96. That's a positive, so that comes out to be 196 over negative 16. We like 196 because the square root of 196 is 14. So now, one of our solutions is x equals negative 10 plus 14 over negative 16. The other one is negative 10 minus 14 over negative 16. The first one gives me 4 over negative 16, which is negative 1/4. Nice number, good solution, but that's the one that's actually over here, and we don't want to know when time is negative. It doesn't fit to the problem. But we look here, and we get negative 24 over negative 16. A negative divided by a negative is a positive. We reduce them by 8 out of each of them, and we get 3 over 2, which is 1.5. So 1.5 seconds is when it hits the ground. So make sure you take the positive one. Yes, negative 1/4 is a solution, but it's the positive one that fits to the context of the problem.